Like no other, this enormous state-of-the-art building dominates the entire city that surrounds it.
The Singapore National Stadium is a truly epic structure.
It's simply, undeniably unique.
You have this beacon of light coming off the top of it.
The multi-award-winning sports arena is a dazzling symbol of Singapore's national pride. But more than that, it's architecture on a scale never previously achieved.
It's the largest free-spanning dome in the world.
How on earth do you build a dome this big?
It's, a real marvel of structural engineering.
When it opened in June 2014, the spectacular ceremony marked the end of a torturous battle against the laws of nature. Physics, as well as the climate, and even the land the stadium is built on, presented a deluge of horrendous hurdles that came close to defeating designers.
Obviously, it's a major project with huge challenges along the way to making it and realising it.
The only way to find out how architects and engineers won the battle to turn the stadium into a successful reality is to take it apart and reveal the innovations hidden within it. The futuristic Singapore National Stadium is the centerpiece of a giant $1.3 billion sports hub. Dreamed up at the start of the millennium, the intention was to give the city-state a glossy new forward-looking image, with a stadium that could host prestigious international events.
Back in 2000, year 2000, Singapore was really looking at transforming itself. It is a red dot, little red dot in the context of neighboring countries and this part of the world. We may be small, but the dreams and aspirations of Singapore is actually very bold, very big.
Today, the stadium stands as a testament to those grand aspirations.
The National Stadium is the largest free-spanning dome in the world, spanning over 1,000 feet. The range of engineering disciplines that we were controlling was beyond anything I've done before in my career.
Designing a venue that delivers a great experience to tens of thousands of people all at once is quite different to any other engineering challenge. And for architects, a stadium can be the most creative project of all.
This is incredibly hard to do. It requires a vast investment in technology to engineer that. And so you have to have the right kind of geological conditions and the right kind of infrastructure systems in place to support the building, both during its construction and during its lifetime.
All of these buildings are one-offs. You're not doing it as number 7 in a series of 10. These are each unique buildings with their own constraints and their own set of reasons for coming up with various aspects of the designs.
The problems to overcome can be anything from crowd transportation to the sourcing of building materials. For the Singapore National Stadium, there is one issue that will never go away.
We are located in a tropical zone where it not just rain, it pours, cats and dogs, right?
In the 1970s, the first national stadium was built on the same site. But it was open air and completely useless against the elements. Right from the start, the brief for the new stadium insisted on a weatherproof roof. The architects could only come up with one solution. It was radical and would be a huge and very public gamble because it had never been attempted on this scale until now.
There's a huge amount of pressure, and you're always feeling that if it didn't work this time, then you didn't have an alternative.
To build an actual structurally sound, solid roof over a stadium is a feat of engineering of some distinction.
For starters, the area of a stadium roof is vast. And that means weight, lots of it. Several stadium roofs have collapsed.
You have to think about the obstacles you face whenever you enclose a stadium of any kind, which is how do you hold the roof up? And in most conventional stadiums, that was done with columns.
Columns are very effective for supporting flat roofs. But any column system inside a stadium has a fundamental disadvantage.
In a large sporting arena, the starting point for the designer is the field of view of the spectator. They want to be able to see what's going on.
You don't want a column interfering with the view of the fans sitting behind it of the action on the pitch. So how do you deal with that?
For the new Singapore National Stadium, any design with columns is ruled out. But a roof is still a requirement, and it must be supported somehow. Architects delve into history for inspiration.
Going back to sort of Roman bridges and the like, the arch has always been a very natural form for resisting uniform gravity loads. That's why they work well for bridges and even naturally, you know, the natural arches that would form in rock.
If you think about the arch, you've got this curved structure, and when you put a uniform weight on top of that arch, the arch basically channels all of that load into the bottom of the arch, but it keeps the entire structure in compression. So what that means is it's being squashed together.
You take an arch and just keep on rotating it, rotating it, rotating it, you get a dome.
Not only is that efficient for resisting a uniform downward load, because it's a three-dimensional system, it actually has quite a lot of resistance to buckling out of shape.
The architects choose a dome for the roof, but they go a step further and plan the entire structure to be contained in the dome.
As is the case with anything, with any building, scale matters. So sometimes when you do something that we know well, but you just do it a lot larger, the impact really is tremendous.
But what about the weight problem that a roof of this scale inevitably poses? The stadium's first secret lies underneath its outer shell. There are no supporting walls. The whole building is basically a roof, a lightweight dome formed by a number of gigantic metal arches. 6 steel trusses span from side to side, and at 90 degrees to them, there are giant transverse trusses. Together, they hold up the whole roof.
Trusses with lattice structures are structural engineers' favorites because they've got triangles in them, and triangles are really, really stable shapes. They don't deform. So if you imagine that you had a rectangle shape, and if you put kind of funny forces onto it, it can deform into a diamond, but triangles just don't do that.
There are over 11,000 tons of steel in this monumental structure. But in 2008, when the design team were still drawing up plans, the global financial crash takes its toll, and steel prices rise all too aptly, right through the roof.
When we initially did the design of this, we had almost double the amount of steel that was in the roof. And then as steel prices escalated, then there was a real drive to say, okay, how can we drive efficiency into this?
To stop the project going way over budget, the team urgently needs a revised design.
Our design mantra was to reduce weight everywhere in the structure of that dome, so we got the best, most efficient shell structure. Everything had to be optimized to minimum weight to make that a very efficient dome.
They create an innovative computer program that can work out the minimum amount of steel that would still meet the structural requirement.
We developed a very bespoke piece of software to achieve optimization of every element within that roof structure, whether that was the thickness of the steel or the diameter of the tube. It was all optimized to make it the lightest steel structure possible.
20, 30 years ago, you just couldn't do that. It would take you years to do the sort of design that we've done here in a matter of months.
The result is a world record-breaking dome that is so large the Sydney Opera House would fit inside it.
All of the sections are hollow, So they're all hollow tubular sections. You make them as thin and as light as you can. You're up here and you're looking at it at various angles, and everything just looks right and it looks in balance, and because everything is here for a reason.
Reducing the amount of steel cleverly saved the budget going bust before construction had even started.
If you took all of the steel in the roof and you melted it down and laid it down on the footprint of the building, you'd only have 15 millimeters of steel.
The structure that makes it up looks really light and elegant and slender. So I think it's, a real marvel of structural engineering.
One challenge down, but the roof design is just the start. Making it hold its own weight is one thing. Firmly attaching it to the ground is quite another. When the high-tech Singapore National Stadium was built, the construction team faced a serious problem. The local terrain was completely unsuitable for erecting a large, heavy building.
Because it's reclaimed land, directly underneath the grass and the topsoil here, we have a lot of what's called marine clay, and marine clay is about as useful as dark grey toothpaste to build a building on. It really is just muck. If you were coming down onto rock, the force from a dome could go directly into the rock. We don't have that advantage here.
The poor ground threatened the whole project, but there was a clever solution right in front of them.
We started with the demolition of the old stadium here in late 2010. The old stadium was crushed up.
All of the concrete was used as either a base or some parts of the ground forming for landscape.
And on top of that debris, a rock-solid base of concrete.
The Singapore Stadium is built off what is called a raft foundation. Now that is a large concrete slab over the ground.
Unfortunately, the raft foundation alone is not enough. The dome's weight pushes out as well as down. It would collapse into a giant pancake unless something holds it in. Once again, the engineers look to historic masters for inspiration.
In historic domes, like Florence Cathedral or St. Paul's, is a chain, a metal chain. So you put a metal chain around the edges, so where all the weight of the dome comes down and is trying to pull out, it's restrained.
Engineers stole that Renaissance concept and came up with what's known as a ring beam. Instead of using a chain above ground, they buried it in the foundations.
In the Singapore Stadium, the dome is restrained at the edge by steelwork, that it must be completely continuous, as if it were a chain, to stop the dome pushing out. It relies upon being one structure with complete undamaged integrity.
So what I'm standing on the edge of at the moment is the ring beam, and it contains 14 ducts of very high-strength steel cables. And those cables, the amount of force that we put in those, we pre-stress them, is around 4,000 tons. So it's a huge amount of force. The ring beam is like a large, very strong elastic band that's pulling it back in so that all those legs don't spread.
Most critical is where the huge trusses meet the ring beam. A single error here, and the trusses would explode out.
So these are some of the most complex and nerve-wracking parts of the project to construct, and we call them the thrust blocks. So the entire roof, which is 9,000 tons of steel and around 15,000 tons total weight, comes down on only 20 of these supports. So you can imagine how hard they're working.
The weight of the whole structure is directed down onto these huge thrust blocks. The only way to understand how they're locked onto the ring beam is to look inside one of them. Hidden within the giant concrete block is the secret. 175 metal rods called shear keys penetrate right into the heart of the ring beam. Their length and diameter perfectly calculated to be just enough to completely secure the truss.
Bringing this down just to get 175 shear keys to sit inside that reinforced mat was one of the most challenging elements of the whole job.
The next aspect of the project is where the real headaches start. The pitch is made of live grass, which leads to another complex engineering problem. The enormous roof has to open and close.
The moving roof did pose challenges for us. Quite commonly they're done on a flatter roof profile, and they're very linear in their opening and closing arrangement. Doing it on a sphere created some real challenges for us.
The movable sections each cover 100,000 square feet. And because they're curved, getting them to move at all is a mechanic's nightmare.
The retractable roof is around 1,000 tonne per leaf. There's 2 leaves that open and close, so the roof had to be very strong and very stable.
The design was for the movable leaves to run on rails. But there was a dilemma. Any expansion or contraction of the metal components could make the panels jam. So they couldn't be too rigid.
We worked out very early that we should have a very stiff fixed roof, but then kind of a floppy retractable roof that could kind of bend and move a little bit.
The solution that engineers ended up using was an incredibly efficient winch system, with winches mounted on that retractable roof to reduce the amount of cable that was required.
When you are wheeling in, it pulls the roof upwards to close. When we are lowering the roof, majority of the lowering, the work is done by sheer gravity.
The roof panels are mounted on rails attached to the arch trusses. Powerful winches on the base of each panel heave them up to close the roof, and the cables take the strain when it opens. But here's where it's really smart. Sensors monitor exactly where the panels are, preventing them from ever skewing more than 1.5 inches. And to reduce friction, the number of wheels in the system is kept to a minimum.
If we reduce the number of points that it actually hangs from, or the driving points, then that also reduced the possibility of the whole thing jamming.
This silver-looking strip is like a barcode, and the position sensor actually reads off this silver strip to inform back to the event control room where the control system is at on the position of the roof at any one point of time. So this is tracked very closely. And one fun fact is that it's so sensitive that even a drop of water would actually cause the entire system to stop.
The retractable roof is a key feature of the stadium. Incredibly, it can open or close in just 20 minutes. Thanks largely to lightweight inflatable pillows of plastic called ETFE, which make up its skin.
Basically, all aspects of the roof movement is actually controlled here from the event control room. We've already done our last checks. Mission control is good to go, and we hit the button.
operating such a huge structure, it's better to have as little heavy elements as possible as we can. One primary reason why it needs to be inflated is to allow water to run off, so that it's not a flat surface. If it's flat, water can collect, or if it's sagging, water can collect.
Today, the maintenance team are out, using a drone.
We're actually flying above and outside of the stadium because we actually get to go to places where even the rope access technicians would have great difficulty getting to. So over there, we are actually able to scan the entire outer shell, outer dome of the stadium itself.
If you're in the tropics or you're equatorial like we are here in Singapore, and you're coastal, then you have salt in the air, you have a hot, humid environment, things rust very, very quickly.
So with the drone, we're actually able to go up there, start to inspect for things, see whether, let's say for example, are there any abnormal rust streaks coming down from the roof? Are there any panels that look misaligned? Is there anything that really looks out of the norm? On occasion, when the pitch is in, we actually use it to monitor the quality of the pitch and to actually see how well the grass is growing on a frequent basis.
Keeping a vigilant eye on the state of the turf is vital for any venue that holds world-class soccer, rugby, or cricket events. But for the Singapore Stadium, it's now especially important, because soon after the pitch was planted, there was a disaster.
Unfortunately, there just wasn't enough light getting into the stadium, and the grass, it died.
The Singapore National Stadium is one of the most high-tech sporting arenas in the world. But when it opened, it had serious teething problems with one vital component: the turf.
In any sports stadium, the pitch will be the crown jewel, because this is where all the football action, rugby action, all those events or activities happen here, and you have a full house of 50,000 people watching. So I would say the pitch would be most important.
One of the huge challenges building a stadium like this is that you've got a living thing at its centre, this huge lawn that's got to be kept in absolutely tip-top condition for international sporting events.
Because we are located in a tropical zone, because we have a retractable roof, it is not so simple to just grow grass in this climate.
So the 5 key elements of growing grass: you need light, water, temperature, air, and of course nutrients. So to keep this grass healthy, these 5 elements are important. In a dome where we have shade and all that, first of all, the light is compromised.
When the stadium opened, disaster struck. At the centre, the crowning glory of this stadium is its beautiful, flat, international quality grass pitch. But unfortunately, there just wasn't enough light getting into the stadium, and the grass, it died.
More than an embarrassment, the withered grass threatens the fundamental viability of the stadium. Detractors call it a white elephant, a colossal waste of money. Footballers like Carlos Tevez are prevented from playing on the substandard turf.
When it got to the point that managers weren't allowing their star players onto the pitch for fear that the terrible sandy condition of it would cause them injuries, something had to be done.
Initial days, we used the stadium growth lights to enhance the exposure of light.
This problem with the grass was so fundamental that they tried everything to solve it. And they spent a phenomenal amount of money trying to just blast this grass with artificial light to help it grow.
But the light isn't the problem. The grass still stubbornly refuses to grow properly. Desperate for a solution, they take a major gamble and commission a brand new type of turf.
We are now currently at the nursery where I grow all my grass, my pitches. And this is where I do all the work, the start of the journey, before all the grass rolls get all rolled up and go into the National Stadium for events.
At an off-site location away from the stadium, Jonathan and his team of horticulturalists experiment with different types of grass.
To some point, my family actually finds it quite queer and sometimes funny what I do. I get out very early in the morning and I come back when sun is setting, and they do wonder what I do until I take them to the park and I explain to them the different grass type and how is it maintained, and they go, wow. We are doing a traction test here, and this is a portable traction tool. And as it rotates, we have a reading on the wrench here, and the time when we stop is when we hear the grass almost tearing, and we look at the reading from here. So a good traction will be about 40. So this is what we're trying to achieve, get it ready for the National Stadium.
Eventually, they choose a brand new hybrid turf that is part real grass and part synthetic fiber.
This is the section of the turf rolls of the hybrid system. It's reinforced turf. As you can see, there's some fibers that's intertwined with the turf grass. Of course, the grass matter a lot as well. It's just a combination of both. That's why it's a hybrid.
The big advantage of the nursery is that spare pitches can be grown here and transported to the stadium whenever they're needed. The hybrid turf has 7% synthetic fibers mixed in with live grass to give the cutting-edge playing surface consistence. A layer of high-grade sand aids traction, but it's a special woven backing that holds both roots and fibers together. A network of subsoil pipes supplies the pitch with water.
The irrigation system is fully automated. I have a computer system in the office where I can do my work and control it, or I can have a remote to control it, and as well as an app on my mobile phone that I can control it while I'm having breakfast. Yeah.
In the past 1 year, it's been very positive. We get definitely a sense of satisfaction of saying, okay, this strategy is working, it's coming along. But then again, there's never a complacency because we are dealing with a natural product here.
The removable pitch is known as a lay-and-play surface. And for the Singapore Stadium, it offers up an added bonus.
We are pretty much a multi-events calendar where we got sporting, we got community events. So because of this, the lay-and-play solution was approached, and it works out very well for us.
They can change the pitch in just 48 hours. But whatever the event, there's one issue that always needs addressing: how to prevent spectators sweltering in Singapore's super hot temperatures. Singapore lies just 1 degree north of the equator, its tropical climate unforgiving. Humidity is consistently over 70%, and the temperature often soars well over 80 degrees Fahrenheit. To avoid the spectator experience being compromised by the extreme heat, the National Stadium's engineers must provide cooling on an enormous scale.
Imagine the biggest room in your house. We're talking about something thousands of times larger. You know how hard it is to heat and cool that room. Imagine trying to do it at a stadium of this scale.
Quite clearly, you can't condition the air from the top and blow it down, because it will just heat up again. One of the essentials about any form of heating or chilling, you don't want to heat or chill a space, you want to heat or chill people.
Rather than air conditioning the whole enormous volume of the stadium, what the engineers came up with was a per-seat addressable system.
Remarkably, cooled air is blown individually to every member of the crowd from below.
The air is being pushed out through below the seats, and you're getting the effect of that as a blanket of cold air local to the seating tier, not trying to cool the whole volume of the stadium.
Pull out the seating, And there is an intricate labyrinth of tunnels. Ducts that send cooled air to outlets beneath every single seat.
So using the concept that hot air rises and cold air sinks, we are able to keep the cool air in the stadium by pushing through the seats outlets and downwards to all the audience. Okay, if you put your hand here, you can actually feel the cool air coming out from the seats.
It's a brilliant idea, but the ducted air still needs to be cooled somewhere.
We have 116 air handling units located at the back of house that provide cool air to all individual seats in the stadium.
Warm air from the atmosphere draws into these giant heat exchangers, where it meets cold water.
Behind me are the chiller plant room producing chill water. And once this chill water leaves the plant room, it travels through the pipes to the individual AHUs, air handling units, so-called.
The challenge here is how to produce very large quantities of cold water on demand.
So one of the solutions they've come up with is to use loads and loads of balls of glycol, so basically antifreeze, which you cool down to a very low temperature before a game, and that means that you can use them to store up all that cold in readiness for the big event.
Glycol works like the ice packs we put in the freezer. It retains cold.
Night before a big match, they'll cool down the glycol, which in turn can cool down the water, and then this water will cool down the warm and humid air, which is then circulated out into the stadium.
Once the cooling is achieved, the water simply recirculates through the system. When the Singapore National Stadium was conceived, one of the most demanding directives was that it should be a multiple function area. Like no other stadium on Earth, it must host soccer, rugby, cricket, and athletics, as well as rock concerts. Each kind of event needs a different sized area. But for all of them, spectators need to be as close to the action as possible.
The only way to make sure people are right at the forefront of the action in loads of events with very different configurations is to allow the seating stands themselves to move. The first thing that happens is that middle tier retracts downwards, and then the front tier of seats can move back, covering those up and making a bigger space in the middle of the stadium.
There's 30,000 seats that move. In athletics mode, they drop down to the ground and they're tucked under the retracted seats. And there's about 5,000 seats that appear in football mode.
The tiers weigh up to 1,500 tons each. So this is an incredible feat of engineering. Hidden underneath the seating bowl is a state-of-the-art lift system.
That's called a Serapid machine. It's a chain-driven machine that crawls around in a trench.
With the help of this machine beneath the tiers, the stadium's capacity transforms 50,000 to 55,000. And for both configurations, designers have maximized the spectator experience by scientifically designing the acoustics. In public arenas, spectators demand excitement. They want a high-volume assault on their senses.
It's always about creating the unforgettable experience for spectators. In the Singapore National Stadium, we've achieved something really special in terms of atmosphere.
An important aspect of that experience comes from the stadium's acoustics.
You want it to be noisy. If you're cheering on the Reds, you want to hear everybody else cheer on the Reds, and the louder the noise, the better.
Acoustics are incredibly challenging because you're dealing with different types of events. So you're dealing with concerts, you're dealing with soccer events, you're dealing with different capacities within the venue, so you have to design for absorption on people being in the bowl or how the sound will be reinforced within that atmosphere.
Here in Singapore, sound engineers applied rigorous science to the choice of materials for the roof. Anything that would absorb sound, like soft curtaining, was rejected.
You want to hear that crowd magnified, amplified. And so in the Singapore Stadium, they've got loads and loads of highly sound reflective surfaces that bounce that sound back at all angles to try and make everything sound as loud and intense and vibrant as possible.
It's very important to have lower part of the roof to be reflective, which can reinforce this excitement generated from the crowds.
Today, Jingfeng is running a test to determine if those reflective metal and plastic surfaces are still performing as intended throughout the stadium.
We're going to play a special test sound to check the frequency distribution at each receiver location, as well as how evenly the sound level is across the stadium. The special sound we're going to play is pink noise, which is a flat sound across the overall spectrum.
Pink noise is sound that's evenly spread between low and high frequencies. If the monitor shows a flat response, it means the space is reflecting all frequencies equally. Any drop-off shows that frequency is being absorbed. The results are all pretty flat. Good news. When a stadium is at full capacity, it is particularly vulnerable. And that means crowd management has to be at the very center of every design decision.
And when the game's done, everyone's out. And so it's 55,000 people want to leave now. Modelling that so that you understand how people can do that comfortably and leave and get to the various transport facilities within a reasonable time frame and comfortable and safely is absolutely critical.
The price paid when things go wrong is the heaviest imaginable.
In a stadium, when it's full, you've got tens of thousands of people all in there at the same time. And we know that we've had some really devastating disasters in the past, whether it's Hillsborough or Heysel.
At both tragedies, critical errors compounded and people were crushed to death. And if fire takes hold at a stadium with poor exit planning, the results can be equally shocking.
And we saw that to our cost at the Bradford Stadium, where there was a terrible disaster about not being able to get people out.
Fires in these sorts of facilities are very, very rare, but the history in the UK has shown that they can occur, and understanding how people will react and making sure that they can react and they can leave safely in a very short period of time is critical as well.
We've designed the building so that the typical scenario is evacuation in terms of a fire or something which requires an immediate local response. And for that, we have an 8-minute time frame in which we're allowed to take people from their seat to a point outside of the stadium.
Planning how 55,000 people can quickly evacuate the stadium is a task where the architects couldn't afford to make a single mistake. A life-threatening emergency at a crowded stadium is one of the greatest fears for any architect.
So it's absolutely imperative that the design of the structure and everything that goes around it is really spot on to make sure that we don't have any devastating consequences from it.
Singapore Stadium's engineers used computers to analyze crowd behavior and help them plan entrances and exits.
These things are amazing to watch because you watch where people crowd and where they congregate and where you're getting too many people, where are the pressure points. And it's really important to find where that's going to occur and then change the design before you've built it.
Part of the design of stadiums is around ensuring that every exit, as you sequentially go to the outside of the building, is getting wider, so you're sequentially able to flow unimpeded at a faster rate out of the building. And a lot of that required us to make changes to the design because some of the widths, even 10-metre widths, were required to increase to 12-metre widths. to allow for counterflow of people under the cover of that canopy.
The status of any stadium is defined by the prestige of the events it holds. One of the most impressive staged at the Singapore National Stadium was the 2015 Southeast Asian Games.
That was a very successful event, and it really showcased how the stadium can be best used for those sorts of events. That was something where the people of Singapore came and really, I think, felt a wonderful atmosphere in here, and I mean, it's their city on display to the world.
But in this day and age, even a world-class event is not enough to draw attention.
Increasingly, stadiums are urban projects that help give identity to cities, and so therefore you want them to be prominent in the skyline and prominent in the cityscape.
So for me, the most impressive thing about the Singapore National Stadium is those plastic cushions at the top that light up and just give the building a huge amount of personality. Right at the crown, at the top of this beautiful dome, is this absolutely startling feature where they use lights to project images and videos, which you can see not only from the inside of the stadium, but also outside from the city itself.
The fact that we have a live roof is very unusual, but it adds to the enhancement of the patrons' experience. So, and this is what we aim. We want to give the patrons, as they're coming in, they can see a lit roof, and once they come into the stadium, it's even a better experience for them.
When there's a goal and it says score and goal and it flashes from one side to the other and there's all this rock music and everything going on, it just really pumps up the crowd, and that's important for the stadium to be successful, but also how it's conveyed on TV for viewers at home.
So in order to create this really impressive display, they've used tens of thousands of LEDs on the retractable portion of the roof.
The vast screen is one of the largest in the world. And because it's made of LEDs, it draws comparatively little power. It's the final piece in this high-tech puzzle and cements the stadium's high profile. Not only is it the largest free-spanning dome in the world, it's prevailed against all its detractors and become a triumphant sport, entertainment, and economic success story.
Stadiums are so expensive, in part because they're among the most profitable buildings you can build. Essentially, a stadium is a machine for making money, which is what we used to call skyscrapers. But I really think stadiums have supplanted skyscrapers as the ultimate 21st century machine for making money.
Against the odds, the Singapore National Stadium has overcome the problems of building on soft reclaimed land. It has a roof of unprecedented scale, and extraordinary engineering enables its seating tiers to be transformed on demand.
I think the emotional part is that it's come true. It's a dream come true. It is one that it will transform our lives.
Just an amazing venue which we as a team are just incredibly proud to see open, and it is about an integrated approach to architecture, design with engineering to achieve what we've achieved.